That's assuming the person's at body temperature at the time of death. What might change that? The temperature of the room, right? I think somebody said they saw one of the CSI crime shows that said that they put a body in an air-conditioned room and then turned the air condition off so that it messed up the time of death and body temperature. So there's all kinds of things that could be a factor. Anything else could be a factor? What if there's a fight before death? Maybe their heat would go up, right? Or they're sick, right? So there's all kinds of assumptions that go into the fact that we're assuming that their normal body temperature at time of death, and now it's going to go down. Fill in this thing, go down a few, and then draw a plot. In that plot, I'd like you to draw time. For biology, time is always on the x-axis, body temperature is here. You guys are okay with this, right? We're making our own math class today. Or we can go back to WebAssign. Kevin wants to go back to WebAssign. You're thinking it. So make a graph and tell me what that graph looks like.
You want the temperature to be the numbers, the actual numbers we got, or like the range?
Well, now I put the numbers in. So what would the second hour be? Right, so you can, I just put the number in, and then, yeah, so it won't be a range, right? Now we know, we're going to use this one, that it's flat for the first hour and then after. But you're right. Clearly in the paper I just showed you, they were not doing that. But most papers I've seen do that. They assume that the body temperature is constant for the first hour. Always, yeah. What's your major? Bio, yeah. Have you? What kind of plots do you do in bio? I'm sure you do plots, right? Isn't it always time? You're looking at something over time. Are you bio too? No? What's your major?
Computer science.
Okay. It's also computer time, right? Give me time. Physics is time. Math is X. Actually, one of the doctors didn't like that I always called the x-axis the x-axis. I mean, that's math, right? We call it the x-axis in math. When you plot that, what kind of thing do you get after you draw it? When you plot the points? What kind of, do you get a parabola?
Linear.
Just linear. So I don't know the history of this rule, but I usually dig up the history when I'm investigating a constant rule. Where did it come from? My guess is that somebody took body data and scatter plotted it and fit a line through it. That's my guess. If anybody has time and is interested, this is a nice thing to do for the spring student research symposium. I haven't had time to do this. So it's not my field, but I think it's interesting, and I always, whenever I teach, I'm like, this is so interesting. It'd be interesting to go dig up the history, look up the rule, see how people use it, and then start saying we're going to critique it right now. So as you're drawing that, can you tell me when we talked about this before, will the body freeze? Because according to this drop, it's supposed to eventually freeze, right?
It's gonna go up at linear, and then it's gonna hit a constant.
Okay, so when is it going to hit, what hour is it going to hit that constant?
Whatever the body.
The 70, do you think it's 75 degrees in here? 70, it's probably, I feel cold all the time.
So like room temperature?
Yeah, room temperature. So at 70 degrees, should we say it is? Do you think it's 70 degrees in here? Maybe. So tell me that, when is it actually going to hit room temperature? You can actually just figure it out, like. So you can do this two ways, right? You can either just make a list and then wait till it hits 7 degrees, or you can I see some people looking at their graph and going, I'm just going to put my finger, it's about here. I find when people do real examples like this, they get so smart. Wait till I tell you what you're doing. If I ask this question as a math question, everybody would be sitting there looking at me. Actually, you wouldn't be looking at me, your eyes would be closed. Can you ballpark it, quasi, yet? Do you see where it's going to kind of happen at? Far down, right? You hire it? You got a ballpark?
I was thinking like 10.
Around 10 hours?
Yeah.
Right, if 9 hours is around 85, maybe 10, what? We already know it for 9, right? It's at 85. So you need it to go down 10 more degrees. 18 hours?
I got like 20.
Yeah, 20 hours, that sounds right. So almost a day. It's almost a day, like a full day after death, that they are going to hit body temperature. Now, if they hit body temperature, let's say you came in and took their temperature and it was room temperature. Can you say anything? Can you say anything about it? Like, you're the crabby CSI person that comes in and the police people are asking you, like, can you tell us when it happened? What would you say? Huh? Yeah, I can only tell you it's 20 hours or more. Right? You can say, you can give a window and say, I know it's more than 20 hours, right? Because you just calculated that it's about 20 hours.
What if the body was discovered like outside? Would it reach whatever outside's temperature was? Or?
Yes, it would. That's something that you learn in general chem called thermal equilibrium, that if you have two mediums, one is warmer than the other, and it's the warmer one is the small medium and it goes into the large one. You remember something like this?
Yeah.
And then they will hit thermal equilibrium. Yeah, that's exactly right. So the graph that you should have got, or you should be seeing, is something that looks, I'm going to draw a mock graph here, it's not a tight graph, like this, down, and then we expect it to do this. We don't expect it to keep going down, right? So that's the first limitation of a constant rule. It assumes that it just keeps going down, and that's not going to happen. A good model should incorporate the flattening out when it's supposed to flatten out, so that you don't have to do that. And you're doing back calculations. That's what you're doing. That's called the inverse. When you do the back calculation, you're back calculating the time of death from the temperature of the body. You're calculating the inverse. Anytime you back calculate, that's what we call it. All right, so let's see some more good questions I can ask you about this. I don't think I've seen you this tired yet.